Hi, welcome back. Today I'll be showing how to use OpenDroneMap within ImageBreed to process your aerial imagery. So the images we're talking about here are either, they can be spectral imagery. So here I'm showing from a MicaSense 5-channel camera. So as you may know, the 5-channel camera collects in the blue, the green, the red, the near infrared, and the red edge. So these are delineated by _1 to _5. And every time the camera takes a capture, you get this incremental capture number. So 20, 21, 22, and so on. So here we have an unoccupied aerial vehicle flying at about 25 meters. And as it flies from waypoint to waypoint, it's capturing images. Here, the flight plan was set such that the collected images have an overlap of 80% on each axis. You can also have color camera images. So here, the camera collects just a single RGB color image for each capture. So those are the two image products that we can deal with. And so now if I go to ImageBreed and I look at field trials, we have two field trials set in this database. If I open up field trial 1, we see the planting date, and we see that it has 5 accessions completely randomized into 4 blocks. If I look at field trial 2, this had 5 accessions in 5 blocks randomized. Now, if I go to manage aerial imagery and I go to upload imagery, we see the workflow and the example data sets. So the MicaSense raw captures and the MicaSense panel image are the data that I'll be using in this demo. The color captures are the ones shown on this screen, and I'll show them in a separate video demo. And of course, you have the previously stitched orthomosaics, which I've shown in another video, and that's if you've used external software like Pix4D or Agisoft to process your images. So here I'll move on, go to upload a single imaging event. In this, you can select one or more field experiments. I'll select both. And what that is representing is that in the course of this flight, I captured those experiments. So I captured both of them. Then I select the date of the imaging event. I'll say it was on December 10th. You can give a time as well. And this was not in a greenhouse or a fixed camera rig. This was collected using a drone in the field. So I say no. Then here I see the previous imaging events that are in the system. And here I have to specify that this is medium to high resolution. I specify the camera types. So have the MicaSense 5-channel, have a couple different color camera types, and then these are single band image types. I select the MicaSense, then I select the drone. You can add a new imaging vehicle if you need. I give a description, so I'll say these are, raw images from MicaSense 5-channel camera. You can also give some weather information, description of the imaging event. Then here on step number 4, I have to select whether I'm uploading previously stitched orthos or I'm uploading a zip file of raw images to stitch using OpenDroneMap within ImageBreed. So that's what I'm showing in this demo. I go to the next, and I have to select a zip file containing all of the MicaSense captures. So this folder I'm showing in the form of a zip file is here, and you see this is a 1.1 gigabyte file. There's no limit to the size of the file that you can select here. And the second zip file that we need is a zip file containing a single capture of the MicaSense radiometric calibration panel. So this was collected immediately prior to the flight in the field, and have the five channels for that capture. And I'm going to upload them as a zip file here. Of course, if you upload a color camera, the color images don't require this radiometric calibration panel. So here I select those zip files. And I select the panel file. And perform radiometric calibration, I'll say yes. And so now that will upload, and it'll process those images into a radiometrically calibrated orthomosaic. It can take up to an hour depending on your hardware and the number of images involved. OpenDroneMap has finished processing. And so if I open up the imaging event, we can see that OpenDroneMap stitched these orthomosaics. We see the blue, green, red, near. You can open up and see the stitched orthomosaic. It's near infrared. That's the red. You can go to the image detail page. You can download the high resolution image. We also have the DSM, the digital surface map. So the DSM is different in that this is an estimated altitude of the objects in the image, in contrast to these spectral data. So the DSM results may vary, but these are estimated heights of the plants in the field. And so in the next video, I'll show how to run the standard process. The standard process is the same whether you upload orthomosaics or images that came from external software, or whether you used OpenDroneMap within ImageBreed to create the orthomosaics. The standard process is the same, and we'll see that in the next video. So stay tuned, and thanks for watching.